Emergency doctors are facing a large number of extraocular foreign body injuries, such as ferromagnetic metal, in the eyes of mechanics while they work on projects that involve grinding metal. The current methods of removal for these injuries are a needle or a device known as an algae brush, which spins a burr and grinds a part of the cornea as well as the foreign body to remove them. This process, if not done quickly, could lead to the formation of a rust ring in the cornea, which is uncomfortable for the patient and could lead to lasting damage in the eye.
The group aims to speed up this process as well as make the process more comfortable for the patient. Our solution uses an electromagnet to pull the rust out of the eye, replacing the need for an algae brush. We also included a feature that wiggles the foreign body, causing it to dislodge from the eye. Using an electromagnet would be much quicker and more comfortable for the patient, as the electromagnet would pull out the foreign body object rather than grinding or flicking it out. Using electromagnet would also be quite easy for new emergency doctors to learn how to use. This process also does not require contact with the patient and can be completed with close proximity rather than touching a nervous patient.
Our final product consists of an electromagnet that is powered and controlled by a box with an interactable interface.
For manufacturing our electromagnet, we first had to find the best dimensions for it by running simulations. To do this, we used MATLAB controlling FEM to run thousands of different simulations and collect the data and outputs of each one.
To power the device, a circuit was constructed. The main components of the circuit are the L298N H-bridge, which allows for polarity switching, used in the earlier mentioned agitation feature, and Arduino Nano microcontroller that continuously runs a script allowing for input and H-bridge control, an LCD that provides visual feedback to the emergency doctor, and button inputs that allow for mode and power level adjustments.
Multiple components needed to be produced in order to complete the project. This included a box to house the circuitry and casing for the electromagnet. They were designed using Autodesk Fusion 360 and were printed using PLA filament and resin ink.
Here's a short clip of the electromagnet pulling rust off of a lamb's eye. This is to simulate as close as we can to a real situation in the emergency room. Thank you for watching, and I hope you guys enjoyed.